Today I want to speak about introducing Jekyll RDF, and we also wrote a paper about it, and the paper's subtitle is a template-based linked data publication with minimized effort and maximum scalability. And the reviewers also, doubted about this claim we made in the title, but maybe we can also discuss this towards the end, if this is really true, but we left it like that. And so the talk will be structured mainly in 6 parts. I will first take you motivate the topic and tell you what is the aim of Jekyll RDF, introduce how we approach this topic, tell you about the core parts of the Jekyll RDF approach or system. Then we will also look into the documentation and the tests, and also the code itself, and the use cases will be presented afterwards, and they somehow also give you some view on who is the community of using Jekyll RDF. And I also have future plans about Jekyll RDF, or about the idea of Jekyll RDF, which I will briefly introduce at the end, and then we will have time for questions. So, motivation and aim. I think you all know the linked open data cloud, or you are somehow familiar, and I think you also have seen the diagram of the linked open data cloud. And linked open data cloud is a lot of data, and a lot of data that can be processed by machines. And this is the aim of publishing structured data on the web. And we also have further RDF documents that might not be open, that might not be on the lot cloud, that might also represent small parts of information, small parts of knowledge that we somehow have on our system. And Tim Berners-Lee and James Handler wrote in their article publishing on the semantic web, the web was designed as an information space with the goal not only that it should be useful for human-human communication, but also that machines would be able to participate and help users communicate with each other. So we have a huge information space. At the beginning, we just had plain HTML files, and people were putting HTML files on web servers and then could read those HTML files. And more, we came up with more dynamic programs so that machines could help us put these web pages online. And now we also have very dynamic spaces where we can communicate with each other in social networks and so on. But still, if we think about the data-driven web, there is the part of the data that is available to machines that we try to structure in a really expressive way, and encode our knowledge and information. But still, we as users, we as people, we as human also want to know about this knowledge. So somehow we have to represent it. And there's some gap. How can we close the gap between structured data and human accessible exploration interfaces? I've brought you a screenshot from the Wikidata, from my hometown Leipzig, where I'm also sitting. So I somehow also feel like being in London, since it's raining here and cold and stormy. But I've heard you also have snow in London. Already have snow in London. We don't have it at the moment. But this is about Leipzig at the Wikidata. And you have some information here that it's the largest city of Saxony. You have it in different languages. And then you have some statements and key value pairs. Also, DBpedia is a huge data set, which brings information about Leipzig. It even highlights and takes us the flag of Leipzig and highlights the abstract of the article. but the rest is also just a key value table. So I would consider those as rather generic interfaces for data. So they give us the data, they show us all of the data, but still keep it in a manner how we represent the data in terms of triples with subject, predicate, and object. While those, I think, are also the web pages that we often see on the web, nicely arranged web pages, which present a lot of content, but not in a tabular way with predicate and object. And so how can we have such customized layouts for graph data? So I think it somehow, maybe we can do it like a form letter, that we have a template and insert our data into the template and then generate our customized layouts from it. I mean, there are content management systems that do it mostly on SQL databases. But how can we do this on graph data, and what are the steps that we need to go for that? So yeah, we jump into the core of the approach, and it's mostly threefold. So we have the aspect of the template mapping. So we need to identify for the data in our graph which template do we want to use to represent this data, or the other way around, which data do we want to show in our template that we have at hand. So somehow we have to match this graph data to the templates. Then we also want to generate pages from it. So we want to represent as HTML pages in the end. So we have RDF resources on the one hand, but we want to have pages on the other hand. And then to have these templates, we also need to have the proper way of representing this markup. So now we directly jump into it. We have the graph with triples, with structured knowledge on the one hand, and we have HTML pages that should come out of the process on the other side. So I start from the end. So how can we process the Jekyll RDF markup? And this is a snippet of template in the liquid templating language that is used by Jekyll. And you have the placeholders with the curly braces, and you can show some title for a page. You can show the date when this page was created. You can convert this date, and you can show the content. So maybe you can just briefly use the chat to give me a short reaction if you have ever worked with GitHub Pages, for instance, or with things like that, just like some kind of emoji reaction. Yeah. Okay. So Eugene has worked with it. Joy Nam, Pascal. Okay. So there are many people who might not have already experience with these kind of templating languages, but I assume you know HTML. And so in HTML, you have the text, and I showed just a snippet of it. And then you insert placeholders with the curly braces, and then these placeholders are replaced by a value of a variable. And this variable somehow needs to get into the context of this page so that it is rendered into it. And usually in Jekyll templates, you add some YAML data to the beginning of your page, and then you have general information about the whole site. So you can also access a global variable to insert this into your page's content. And this is, just the same process as for form letters. And with Jekyll RDF, we now want to insert graph data into this. And so basically, Jekyll RDF has defined 6 new functions, or they are called filters in liquid, and it is RDF get, which is a filter which we can execute to get any resource from a graph. So we we insert the IRI into this filter from the left, and then on the right we will get the resource that represents this node in our graph. And with this node, we can then further process and get properties of this node from the graph with the RDF property filter. But we also have the specific variable page.rdf, which will represent the core resource about which this page is speaking. And we can take all of these variables and then walk through the graph with this RDF property function and go from property to the next node and then to the next property and to the next node and the next property. With inverse property, we can go the whole way backwards and take incoming triples. So if we are speaking about a resource, then we have a triple SP, this resource, so we can get to the S value. Collections and containers are helpers to work with RDF collections and containers, since they're not easy to process if you always have to walk through the graph with the properties. And a very mighty filter is the SparkQL query filter, with which you can execute any SparkQL query inside your template and then use the output of the SparkQL query to render your page. And I would say the mostly used properties which I use in my templates are RDF property and SparkQL query, actually. While the others are also very handy in many situations. And then the resulting Jekyll RDF code for this would look like, we see it on the screen here. So as I said, we have this page.rdf resource, which represents the current page's resource, and page.rdf variable, which represents the current page's resource. And from that, we want to take the RDFS label in English, for instance, and we want to know what is the DCT created property of it. And then we also want to format the state. So integrating just these simple Jekyll RDF filters enable us to also use the huge amount of liquid filters that are already available in the liquid templating language. Even with the for loops, we can go through a container in this case, for instance, and print some simple publication list in this case. Now, I already went forward and told you about this page.rdf, but how do we actually get to this page.rdf variable? If we have in our graph, for instance, a variable, IRI, like this http //fachhochbuch.aksw.org/sachsen/ort 3441. If we have this resource, then we need to take this resource IRI apart, and we strip off the schema in the front. We have the authority in the middle, and then we have our path. So in the configuration, this is why I wrote config over here, of Jekyll RDF, we configure some URL, which is already there in the general Jekyll configuration system, which will represent the schema and the authority part. And then in Jekyll, you can also configure a base URL for your site, which will then also be stripped off from our IRI. So those are the things that need to be matched in the most common ways when using Jekyll RDF. And then we are left with a part of the path of our IRI, which is auth/3441 in this case. So with the Jekyll RDF page, we just add a .html extension to this path, and then we have our actual file path for where we want to render our resource. This seems to be simple, but it really needs to be, you need to think about it when you implement it to really map the URLs, because you will have a lot of URLs, for instance, HTTPS and not HTTP. And here we come to the point that it's always important in RDF that you really have the same lexical representation of your URL as you're looking for. And so we just map the exact matches to these paths. And then we also have often these hash URLs, which are very common if we speak about vocabularies, for instance. And since this hash will never be forwarded from the browser to a server, we also need to get rid of this in our representation. So all of these resources which have a hash identifier will be categorized as sub-resources under the parent path. So we have some hierarchy, and we need to put a lot of semantics into path, which is not very common in RDF, since a URL should just be any identifier. And then from this, we can say for this page, auth/3441.html in Jekyll, the page.rdf variable will represent this IRI in our graph. And now that we have mapped our graph resources to pages, we are also able to link to other resources in our template, so that if we find some resource that is connected in our graph to another resource, and then we want to render a link to this other resource's representation in our set of HTML files, with this mechanism, we can also find the route to this other path, which we have to put in our hyperreference for our link in HTML to actually navigate through the pages. And so besides the representation of the templates to render resources, to have these interfaces, a important part is the browsing, so that we can actually click through the resources to actually explore our graph as connected data. And now the first part, which actually happens, is the template mapping. For a resource, we need to identify which we know for a template which resource is filled in with this page.rdf variable. But actually before that, we need to decide which template do we want to use to render which resource. So we have the template mapping process, and usually in RDF, it is very common to have types for your resources. So a resource is assigned to a class, which is then the type of this resource. And a resource can have multiple types, in this case 2, in this case even 3. And the classes can be in a hierarchy of classes. So they have subclasses and superclasses. And it's even possible that a resource is typed with, in this case, for instance, that this resource is of this subtype of this type, but also explicitly stated that it is of the type of this superclass, while it is still inferred that it is also part of the type of this upper class over here. But we look at the stated links, so those triples can be inferred, but we just look at the triples that actually are present in our graph. And then in the configuration, we can have a mapping from the classes to the template. So the stars represent our templates, while the circles represent our classes. And for a resource, we need to find out which template do we want to use to render this resource. And for instance, this resource is not of any type that is directly assigned to a template, but there are superclasses which have a template, or in this case, there are two classes with a template, so we have to decide which one we take. And for this, we have some selection algorithm. So for this resource, I think it's clear. We have a path of distance 3 to this class for which we have a template. For this one, we have a path of distance 2 to this template, while it would be 3 to reach this template. So we end the search over here and we take the closest template. And in this case, we can't really decide it since there are two templates which are have the distance of 3. So we need to randomly select one, and we output a warning in this case, so that you take care to specify which class you want to use. But also in this case, there is the this template which is distance 1, and this template which is distance 1. And in this case, we take the most specific class, so the lowest in the class hierarchy. So templates are selected based on the type's shortest subclass path. And I think the gist is just that we take it, decide on the template based on the class. So a class defines the type of a resource, and so I think it's a very simple case to just say things that are of the same kind should look the same in our representation of the graph. So now let's take a look into the code. And I've introduced you into these 3 steps, and these 3 steps are marked over here in this BPMN workflow. So we have the template mapping, we have to map the resource IRIs to page paths, and we have to process actually the Jekyll RDF markup. And this is all integrated into Jekyll as a Jekyll template, as a Jekyll extension, as a plugin. So this is the usual flow of things in Jekyll, and then Jekyll calls all of the plugins, and then finally it processes the markup, the liquid markup on the files, then converts Markdown to HTML, and finally writes our rendered pages to the disk. And besides the pages and the layout templates, which are used by Jekyll, we also have additional Jekyll RDF configuration, which is inserted in the Jekyll configuration. So actually, I should put a document down here for the Jekyll configuration as well. And we have our RDF data that is consulted in all of these 3 steps. So first to choose the template, then to map the resources to IRIs, and then to insert the data into the template. And in this moment here, we actually generate the objects that are needed by Jekyll to represent the pages in its internal data structure. So I think that's also pretty straightforward process. The whole thing is written in Ruby. And since this is the language in which Jekyll is written, and why did we choose Jekyll at the beginning? We chose Jekyll at the beginning because that was, for me, the most popular static site generator, as of my perception, since it's also used in GitHub Pages, which it is still. On Jamstack, it's even the 6th static site generator. There are more popular static site generators like which are written in JavaScript, and also Hugo and Go, but still Jekyll is pretty popular still. And it provides us with Markdown, and we have this nice layout templating. The result of our whole process will be a self-contained web page as static pages, and then we can take these static pages out of this process and serve it with minimum effort using, for instance, Nginx, GitHub Pages, or any static web space that is rather cheap compared to web space where you also need computing power behind it and to maintain software updates. And Jekyll also comes with the liquid templating language, which is quite powerful and extensible. You can introduce new filters, and other people do it as well. And so you can also use other people's plugins. And those are basically the reasons why we chose Jekyll and why we wanted to have a static site generation system to represent our RDF data. But at the beginning, Eugene mentioned that I'm the author of Jekyll RDF. I somehow want to tell you that I'm definitely not the sole author, and I think it's only really few parts of the lines of code that actually I have written, since at the beginning I took this idea to a student group which had to do a software development project at our university, and I asked them to build Jekyll RDF for me as part of this assignment, and they did a really great job, and more or less they came pretty close to what we see now for Jekyll RDF. And then I also had another student worker. He is also co-author of our paper, who further helped me to maintain and further develop Jekyll RDF in many parts. And then finally, since I was so happy about that my idea actually worked and that the students gave me such nice code to work with it, I did a lot of experiments and could include it into the whole overall technology stack for my doctoral thesis as publication and exploration interfaces, since I've worked with Git-based data management workflows, which is the core contribution of my thesis, and such static site generation tools combined with continuous integration really blend in nicely. If you want to look into the code, you find it on GitHub at AKSW, in the AKSW space, which is my current or former research group in which I worked. You also see some pictures of the students who did it at the beginning for me. We are now at the version 4.2.4 of Jekyll RDF. In between, you can see we broke the API 4 times to not be backward compatible, since we also made some improvements, and the code has a code coverage of 92%, which we are also very proud of, and the documentation is mainly in this README file. That's maybe not the nicest way to represent the documentation, but it works, and I hope it has everything in it. And the last time that I've updated it was 5 months ago. The system is barely further developed at the moment, since it has proven itself to be quite stable, and we just need to do some maintenance updates if Jekyll changes things, or if other the RDF libraries in Ruby or other Ruby libraries change their API or find severe bugs. It's also published on Ruby Gems, so you can use it as a Ruby gem in your project, mostly in combination with Jekyll as a plugin. And many people do it, or I would say quite some people use Jekyll RDF. One system that came out of Jekyll is the JOT, the Jekyll ontology documentation, which is basically a very sophisticated template that is rendered with Jekyll RDF to document ontologies. This is an early version of this template, as it was used as you can see, in 2019 for the interlinked video games database vocabulary, where some colleagues at the Leipzig University Library researched in Japanese video games and made a vocabulary for that. But it's also used at the moment at the German National Library. And it was actually used there before I joined the German National Library. And it's used to publish the documentation of the GND ontology. And also it is used at my former employee Eccenca, and which also mostly did the development of this JOT ontology documentation before I joined the company. So to show you this live use case for the GND ontology, you can see it's like for other ontology documentation systems, you can browse through the classes over here and the properties. You can click to directly jump to the properties, but you can also look for some things over here. You have a search. You can say collective manuscript is something that I find interesting, and you can also see the relation to for instance, that it has the superclass work, and jump around in here. So you have a single page representing this vocabulary. But it's also used in research projects and research groups. So AKSW, Agile Knowledge Engineering and Semantic Web is the research group where I did my most of my research, and where I'm still more or less a member of. But also for the Smart Data Analytics group, they use Jekyll RDF to represent their team page. We used it in a research project Pfarrbuch, from which I also took the URL example, where we have data about pastors in Saxony since the Reformation. So we work with theologians and historians together to represent this data, and they wanted to have a human accessible interface to the data set that we have created for them. And also in the Moon multilingual morpheme ontology use case, we looked deeper into the Hebrew language and took it apart, and then also wanted to represent the findings of the individual roots and binyanim of the Hebrew words in some domain adapted way. A particular example where I'm pretty proud of, which I've shown at the beginning, is the whole event webpage for our Data Week Leipzig event, which will take place the fourth time this year. Next year, I think it's the fourth time. And this webpage from the beginning on was built with Jekyll RDF, and I and a colleague of mine, Norm, we put a lot of effort into the implementation of this page, and we have quite some templates which you can also use to see how you can do things with Jekyll RDF. So everything, the menu structure, the language switcher, all of these links are represented in an RDF graph in the backend, which is also hosted on GitHub. And also, for instance, the keynote speaker in this case, the information is taken from the graph, and also the whole program is taken from the graph and then rendered into static pages. So we don't care very much how many people look at the event web page, since it doesn't cost us any CPU power to serve this page about all of these details of this event. So there's also no chance that this, or a very minimum chance that this web page will go down during the event. In the future, I have some plans. So I want to do a complete re-implementation of this process in Python using the Ginger templating system, since I think that Ginger is a very commonly used templating system. My wife asked me why I will not re-implement it in Rust, make it faster, and that's a fair point. But actually, I'm not yet familiar with Rust, but I would like to be. So if there's someone who says, yes, Rust is my thing, then please come to me, and I want to learn Rust, and then we can also do the whole thing in Rust. And to make it much more scalable, I've started with a re-implementation in Python. I didn't put it on GitHub so far. And I also want to take the parts apart. So I don't want to have these 3 steps as one thing in this Jekyll RDF extension, but I would like to have this markup part separate so that you can also use it as a command line tool, for instance, to use it in combination with LaTeX files and LaTeX templates, so that you can do this form letter thing actually with LaTeX and have your graph and generate and fill the graph data into your LaTeX template, for instance. And then you could also use it in a hybrid fashion for static pages and dynamic pages. And then I could have the part of the mapping and the class selection separate, integrated into some Python static site generation system. Those are my plans. There's not a lot to see so far, just some MVE, which I did last night, but yeah, it's not really easy to see at the moment. And the summary is, yeah, I think the core are these 3 parts to have such a integration of Jekyll, and yeah, and the source code is on our GitHub page in the GitHub repository over here. And yeah, I didn't put the paper, so if you would like to read our paper about it, it's on my webpage. Yeah, actually, this is also a use case for Jekyll RDF or a showcase for Jekyll RDF. So my publication list is, of course, built with Jekyll RDF, and these individual publication pages as well. And here you will also find the figures that you know already from the presentation. Yeah, so I'm very open for questions.